Hi friends, good morning. Today we are going to start with some problems based on the last lecture. Here, last class we have seen what is Newtonian mechanics, how to draw free body diagram to find a different acceleration, right? Acceleration of the body. That and all we seen. And first problem. Here one problem given. Two masses M1 5 kg, M2 10 kg are connected at the ends of an inextensible string passing over a frictionless pulley as shown. When the masses are released, then the acceleration of the masses will be. So here mass M1 given, here M2 given. Now M2 is more, so it come down with an acceleration A, then it go with acceleration up, right? Why? Because in a connected, this is a connected system. In a connected system, body get a common acceleration A, but the direction is different. So here we can write here downward force is M2G, and here downward force is M1G, and here some tension T act here, and it is a connected string, so same tension here active. Now we can solve two equations. It is going upward, this side going upward, so T minus M1B, tension is more, T minus M1G is equal to net force, that is M1A, as per Newton's law, that is M1A. Here this part is coming down, so net this force is more than M2G minus T is equal to M2A, that is the net force on this mass M2, right? M2A. Now by solving this, by adding this to this cancel, we can write M1 M2 minus M1 into G is equal to, right, M1 plus M2 into A, right? Then what is acceleration? Acceleration is equal to M2 minus M1 by M1 plus M2 into G. And these masses are given, right? What is masses? 10 minus 5. 10 minus 5 divided by, so I can write 10 minus 5 divided by M1 plus M2, 10 plus 5 into G. That is 5 by 15, that is G by 3. A is equal to G by 3. So this is the answer. That is the acceleration of this body, right? Then G by 3 is the answer. Now another question is, see, two masses 40 kg and 30 kg are connected by a weightless spring passing over a frictionless pulley as shown in the figure. The tension in the string will be. So definitely in an inclined plane, what you have to know, one body you placed here, we already seen what is the acceleration. Theoretical section we studied. Here mg downward, then which component is in this direction? This is theta, this is mg sin theta, and mg sin, sorry, this is mg cos theta, that will cancel with the normal reaction, and because of sine component mg sin theta, this block come down, right? So what is the force in this direction? Here m2g sin theta, that is m2g sin theta. Here that is m1, so here that is m1g sin theta, but both angle is 30 degree, right? Then theta is here 30, here 30, right? M1g sin. Then what is the net force? They are asking about the tension in the string will be. What is the tension, right? So we need the tension. Before that, what is the net force, common acceleration we need, right? What is acceleration? Acceleration is equal to net force divided by mass, net mass. So what is net force? Higher force, here more mass is this, then higher force minus lower force, then because it is acting in the opposite direction, m1g sin 30 minus m2g sin 30, right, divided by m1 plus m2. Okay, now you are getting acceleration. M1 given, M2 given, G approximately you can take as 10 meter per second square, By substituting all these value, a you can write as what, m1g, this g10 you can take out, and 30 is sin 30 is 1 by 2, then m1 divided by 1 by 2, 20 into that is 200 minus, all right, here 200, m2 is 30, then 15 into 10 150 divided by total 30 plus 40, that is 70, right. Then what is the total? 50 by 70, that is 5 by 7. A is equal to 5 by 7. Now we need what is tension. How we find tension? Now here one free body diagram. Here what is m2g minus m2, sorry, we can take this side. Here this only maximum, then downward, this part is going downward because this part is more mass. Then m1g sin theta, m1g sin theta minus this force, opposite force t, minus t equal to, that is the force acting on this by Newton's law, that is 40 into this acceleration 40, this is ma, m is what, 40, 40 into acceleration we solved, that is 5 by 7, 5 by 7. Then m1g sin theta is 200, right. 200 minus this 5 into 4, that is 200, 200 by 7, 200 by 7 is approximately 22 point something, right. Then 200 by minus sorry 28 something equal to, right, this is equal to tension. Then 200 minus 28 is approximately, that is 168, right, sorry 160, this is 200 by 7 approximately, that is approximately 2, that is 14 60 60, how 7 is almost some 5 7, so approximately 168, 200 minus somewhat is 168 Newton will come. All right, all right. Now let us go to another question. A body takes time t to reach the bottom of an inclined plane of angle theta with the horizontal. If the plane is made rough, time taken now is 2t. The coefficient of friction of the rough surface is. See, this is a beautiful question. See, one inclined plane you have, right? Suppose a body start from here, right? If this here smooth surface, then time taken by this is t. Okay, then what is this body, what acceleration it has? We already seen g sin theta, downward acceleration is g sin theta. Then what is the displacement? Half g sin theta into t square, because starting from rest, right, now half at square format, but acceleration is g sin theta. Now if I make this body rough, suppose I make this body, suppose rough with frictional coefficient mu, then g sin theta no change downward, but one frictional force active. What is that frictional force? See, we told the weight acting mg, then this is theta, means this also theta, then this is mg cos theta, then normal reaction mg sin theta, right. Then force of friction is equal to mu n. What is normal reaction? Normal reaction, sorry, this is not mg sin theta, this is normal reaction, right. Normal mg cos theta is equal to normal reaction, then mu mg normal reaction is equal to mu mg cos theta. Then what is the net acceleration? G sin theta minus f. Then nu s is equal, but this distance, traveling distance not changing, s is equal to half into g sin theta minus what is the new acceleration? This is mu mg cos theta, force only, if mu remove means mu g cos theta, that only acceleration corresponding to that, then mu g cos theta into, but time, that time if it make Rough means it will take more time to reach here. That time they given here 2t. What is that? 2t square. Now you can equate this. By equating this t square cancel, half cancel. What is remaining? G sin theta is equal to here 4g sin theta, 4g sin theta minus 4 mu g cos theta. Right? Now this I can write as 4 mu g cos theta is equal to what I can write 3g sin theta. Now g cancel. What is mu? Mu is equal to 3 by 4 sin theta by cos theta tan theta. 3 by 4 tan theta. Right? So which is the option come? Option A is correct. Right? All right. Now let us go to another question. A block of mass m starting from rest slides down a smooth inclined plane with gradient theta means this inclined plane theta, the lift moving upward with acceleration a0, the base of the inclined plane of length l, the time taken by the block to slide from top to bottom. Right, see here one inclined plane settled in a lift, and lift is going with the acceleration a0 upward and inclined plane angle given, then now they given the lift base is equal to inclined plane base, that is of length L. Now what is the acceleration here? See, one lift problem what we studied, one lift moving upward means with acceleration a, the net weight acceleration is g plus a. If lift moving downward with acceleration a, then net acceleration is g minus a. Now this is why when you are traveling in lift downward, acceleration get decrease. That is why you are feeling some weightlessness, right? That and all you studied in lower classes. Here g plus a if it is going upward. So here see, or basically we can say here this we can say this here already it is g, right, mg acting downward, right. Now lift going upward means another acceleration due to fictitious force, if this go up opposite acceleration also acting, so that's why here g plus a. Now here the net force we studied g sin theta only. Now the new downward force what is g plus a sin theta only, right. Now we can write the equation. Time only they asking. What is the, suppose this distance, say this distance, this inclined plane distance, suppose a body start from here, it travel a distance s, then only it come to down. That time only they are asking the time taken from top to bottom only. So distance s is equal to half into, right, half at square. Then what is the acceleration here? We told acceleration is g plus a sin theta. What g plus a sin theta, then half at square, that is g plus a sin theta into t square, right. Now what is s? S from this figure I can write as cos theta is equal to adjacent divided by that distance traveled by the body, right, L by S from this triangle, right. Then S is equal to L by cos theta, right. Then you put L by cos theta here. L by cos theta is equal to 1 by 2 into g plus a sin theta into t square. They are asking the time only, then you can write 2L, right, 2L and sin theta cos theta, right, divided by g plus a into sin theta cos theta, right, sin theta cos theta all raised to 1 by 2, right. Now you may write, I am erasing this, the sin theta cos theta you can write as sin theta cos theta, you can write as sin 2 theta by 2, right, because sin 2 theta is 2 sin theta cos theta. Then you can This is sin 2 theta by 2, you can write as 2L divided by G plus A into sin 2 theta divided by 2 all raised to 1 by 2. Then this 2 go up, then 4L by G plus A sin 2 theta. So let us go to the answer. 4L divided by G plus A sin 2 theta all raised to 1 by 2. Then option B is correct, right? Alright, then this is the answer. Now let us go to another question. Alright, so the question is, in the arrangement shown in the figure, the ends P and Q of an unstretchable string that is moved downward with a speed v. Pulley A and B are fixed of mass m, moves upward with a speed c. One pulley here connected, here connected. Now using a string it is connected like this, and a mass is connected at the middle. Now this end moving with velocity v, this end moving with velocity v. Then say then this mass, suppose it is going downward with a velocity v, automatically the mass go up. This mass upward moving velocity only they asking, right? So if you consider this triangle here, right, whether the string is moving up also, this length say constant, because this length never changing, pulley separation not changing, but this length changing. This length say I can write as y. Okay, this length string also, this string is going downward like this, so L also changing. So from this what I can write, L square is equal to y square plus c square. Now differentiate to both sides. 2 into 2L into dl by dt is equal to 2y into dy by dt. This c is a constant, then plus 0 differentiation. Now 2 cancel. What is L? L into, right, dl by dt. What? This length is going, see this part is going downward with velocity, means this dl by dt is this velocity. The string length only changing, right, in this direction. Then dl by dt is v, right. What is y? Y into, what is dy by dt? V by dy by dt, right. Now we can find, suppose here they given one theta, right, this is y, this is L. What is cos theta? Right, cos theta is equal to adjacent side y divided by hypotenuse L. Then y I can write, y is equal to, I can write as L cos theta. L cos theta into dy by d theta, that is the velocity of this mass rising, right? That only we want to find it, v dash. Now L cancel, then v dash is equal to what? V by cos theta. This is the velocity of mass rising, then v by cos theta is the answer. Then which is that answer? Option D is correct, right? All right, now let us go to another question. Here a block of mass 0.5 kg as an initial velocity 10 meter per second down an inclined plane of angle 30 degree. The coefficient of friction between the block and the inclined surface is 0.2. The velocity of the block after it travel a distance 10 meters. See, that means one block at the inclined plane, it traveling down a distance 10 meter, right, and it's angle 30 degree. This coefficient of friction value they given the surface, that is 0.2, and what and all initially, so okay, block mass 0.5, initial velocity 10 meter per second down an inclined plane. Now see, always you have to think, that is the only parameter we need. Always we have to think, in a rough plane, if a body come out, g sin theta is downward acceleration, mu g cos theta, mu g cos theta is the frictional acceleration. Okay, mu mg cos frictional force, that is normal reaction. We know this is mg, this is mg cos theta, this is normal reaction, right? Now frictional force is equal to frictional coefficient into normal reaction, right? Normal reaction, what this is equal to this mg cos theta, then mu mg cos theta, right? Then what is the acceleration corresponding? Mu g cos theta. Mu g cos theta. So in a rough inclined plane, the resultant acceleration you can write as g sin theta minus mu g cos theta. G sin theta downward and mu g cos theta upward is the resultant acceleration. Right. Now initial velocity given, then equation of motion what v square is equal to u square plus 2as. Now this s distance moving they given 10 meter. We need to find a velocity of the block at a distance 10 meter. Then that means final velocity v square. That is u square they given 10 square. 10 square plus 2 into this is the acceleration, that is 10, right, 10 into sin theta sin 30, that is 1 by 2 minus mu they given 0.2 and again 10 and cos theta root 3 by 2. Now by solving you get a acceleration, right, then acceleration also there, and s given as 10, right, so it is moving, s is then acceleration, this value 5 minus this is 2 by this is 2, 2 cancel, and root 3 is approximately 1.7, 5 minus 1.7 is approximately 3.3, then 3.3, right, 3.3 into s already we know that is 10. Now this is 33 into 66, then v square is equal to 100 plus 66 what, that is 166, that is approximately v is equal to 13, right, 116 and root is 13, then answer 13 is correct, right. All right, now let us go to another question. A system consists of three masses m1 m2 m3 connected by a string passing over a pulley p, like this, see, like this, three masses given, right. Now what we need to find, we need to find the pulley is frictionless and the downward acceleration of mass m1 we need, right. See, here you have to think, here downward force is m1g. Now here friction is there, they given, then here one frictional force, it is pulling towards in this direction due to mass m1g. Now m2 they given m1 is equal to m2 is equal to m3, right. Now due to this pulling, it is there is a frictional force. What is frictional force? Mu 2 mu n, but here it has a weight m2g, so normal reaction n. Then what is frictional force in this direction? Frictional force is mu into m2g. And similarly this m3 also acting another frictional force here, that is mu into m3g, right. Then what is the resultant force? We need the resultant acceleration of m1, right. What is acceleration? Acceleration is net force divided by net mass, okay. Now what is net force? A is equal to total downward force minus total opposite force, right. m1g minus what is this force? Mu m2g, mu m2g minus mu m3g divided by net mass m1 plus m2 plus m3. Now it is given that all the masses equal, right. Then you can take m all out, then g minus here mu g, here mu g, then m I taken out, then 2 mu g divided by here m plus m, all the masses are equal 3m, then g minus 2 mu, right. G also we can take out, g into 1 minus 2 mu divided by 3, then option C is correct. All right, all right. Now let us go to another question. It is the final question. See, here a block of mass m is in contact with a cart C as shown in the figure. The coefficient of static friction between the block and the cart is mu. The acceleration alpha of the cart will be prevent the block from falling, right. See, you already know one vehicle is going in this direction. Now one body attached here, without falling this, it will keep because of this speed, right? For that, what is the maximum acceleration we need? Suppose vehicle getting one acceleration, say alpha, in this direction, then this block get to opposite acceleration alpha, right? That we studied as a fictitious force acting on a body, in a moving body, right? Now what is our condition? If alpha, this block producing on the vehicle, then normal reaction n. So if this mass m alpha, right, then normal reaction m alpha opposite getting, right? Equal and opposite reaction. Now if the body is not falling down, means the body has a weight mg, and this surface, with this surface, this body has a frictional force Fr, right? This Fr and mg equal, then only body not falling down, right? So I write frictional force is equal to mg. Now what is frictional force? Frictional force is equal to mu into normal reaction n mg. What is n? N is equal to m alpha, right? M alpha is equal to mg. Now m cancel. Then what is the maximum acceleration I required? Alpha, what I required, that is g by mu, minimum. Or it should be greater than, alpha should be greater than or equal to g by mu. Then this block we can keep here without falling, right? Then which is the option? Option C is correct. All right. All right. Now this is all about this topic. Next time we start with rigid body dynamics, center of mass, etc. All right. Thank you.